Imagine someone saying, let's build a telescope powerful enough to look back to the beginning of time itself. Sounds impossible, right? Yet here we are. The James Webb Space Telescope didn't just do what we dreamed, it went beyond. What it's uncovering isn't just another cosmic photo or deep space find. It's rewriting the very rules of our existence. Every tiny dot in those breathtaking images, not just stars, but entire galaxies, some so enormous they make our own Milky Way look small. Webb has gazed farther than any human instrument in history, peering into the universe's first light, the moment stars and galaxies were just being born. But what it found doesn't match the cosmic blueprint we thought we understood. In regions that should be shrouded in darkness, Webb spotted brilliant, massive galaxies glowing like lanterns in the void. Gas and dust swirled violently, heated by collisions that seemed to be happening far too soon. Even the world's top scientists, people who've dedicated their lives to understanding the cosmos, are stunned. The universe, in its infancy, appears to have broken its own rules. It's as if we're peering into a different reality altogether. Things are forming faster, brighter, and in ways that defy the laws of physics. And that leads to haunting questions. Are we seeing the first signs of another universe? Or is this some kind of cosmic illusion, a veil between what we think we know and what truly is? When Webb began sending back its first deep-field images, every frame felt like stepping into a new era of discovery. Scientists expected faint whispers of newly forming galaxies, fragile clusters of dust and light. Instead, they found fully mature galaxies shining boldly, as if the universe had skipped ahead billions of years. Among them was a peculiar yellow blob that caught everyone's attention. It was so bright, so massive, that astronomers assumed it must be much closer to us. There was no way something like that could exist just a few 100 million years after the Big Bang, at least according to every model we've ever built. But when Webb's spectroscopic data came in, the truth hit like a shockwave. That nearby blob, it wasn't close at all. Its light had been traveling for over 13 billion years, one of the most distant galaxies ever seen. And it wasn't alone. All across Webb's early images, similar bright galaxies appeared. Countless cosmic seeds scattered across the darkness, each one fully formed, dense, and bursting with stars. According to the universe we thought we knew, they shouldn't exist. But there they are, shining defiantly across time, whispering one truth to humanity. We've only just begun to understand the universe we live in. They looked ancient, too ancient. Organized, structured, and glowing with the quiet confidence of age, as if the universe had somehow hit the fast-forward button on its own evolution. The question struck astronomers like a thunderbolt. How could galaxies like these exist so soon after the dawn of time? To build something so vast, you'd need stars. To get stars, you'd need clouds of dust and gas collapsing under gravity, a process that takes millions of years. But the early universe shouldn't have had that luxury of time. Puzzlement turned to disbelief. Could this be a glitch in the telescope? A calibration error? Some data distortion? Yet the evidence refused to disappear. The same patterns, massive, luminous galaxies, appeared again and again across Webb's images. Independent research teams reanalyzed the data, and the verdict was unanimous. This was real. What began as a discovery had now become a cosmic mystery. A question older than humanity itself resurfaced in a new and unsettling way. How did we get here? Because if these galaxies truly existed just a few 100 million years after the Big Bang, then the early universe wasn't behaving as our physics predicts. It wasn't following the rules at all. That realization sent shockwaves through the scientific world. For decades, the Lambda CDM model has been the bedrock of cosmology, the framework explaining everything from galaxy formation to the cosmic microwave background. It told us the universe is mostly made of cold, dark matter and dark energy, shaping and stretching the cosmos over billions of years. For so long, it felt unbreakable. But now the James Webb Space Telescope is tugging at its very threads. These new galaxies aren't just weird exceptions, they're outright contradictions. They're too big, too bright, too early. According to our current understanding, there shouldn't have been enough matter or time for such giants to form so quickly after the Big Bang. The equations no longer balance. The timeline no longer fits. To create galaxies of this magnitude in just a few 100 million years would require nearly all the available hydrogen and helium, the universe's original ingredients, to have been converted into stars at impossible speeds. But that's not how nature works. Even the most intense star-forming regions we've ever observed move at a fraction of that pace. The universe, it seems, was in a hurry, but our physics wasn't ready for it. Scientists tried to adjust the math, tweaking the star formation rates, changing assumptions about early cosmic conditions. But each fix unraveled another part of the theory. It's like trying to patch a dam with paper. The moment one hole is sealed, another bursts open. The issue isn't in the data, it's in the foundation of our understanding itself. Now even Nobel Prize-winning physicists are beginning to voice what was once unthinkable, that our entire model of the cosmos might need rewriting. Some propose that dark matter behaved differently in the early universe, influencing galaxy growth in unexpected ways. Others whisper about new physics, ideas that stretch beyond our imagination. And then there's the boldest theory of all. Maybe these aren't early galaxies at all. Maybe, just maybe, we're looking at something entirely different. A cosmic mirage, a clue from another reality, or a sign that the universe is far more mysterious than we ever dared to believe. If the model collapses at the very start, then everything we've built on top of it, every law, every theory, every assumption, starts to tremble. And that's exactly what's happening. If our most trusted cosmic blueprint can't explain what we're seeing, then we may be standing on the brink of a scientific revolution, one powerful enough to rewrite the story of the universe from page one. At first, astronomers thought it was simple enough. The James Webb Space Telescope had spotted galaxies that had just formed faster than expected. Nothing too wild, just a little ahead of schedule. But as more data streamed in, that neat explanation started to crumble. Webb's new deep field images reached back toward the beginning of everything, and what it found wasn't just early galaxies, it was something different altogether. These objects didn't behave like any galaxies we know. Spectroscopy, the tool that lets scientists read the fingerprints of light, brought the real shock. It revealed that some of these ancient structures had turned nearly all of their gas into stars. That's completely unheard of. Modern galaxies use only about 10% of their gas for star formation. The rest lingers, swirling in cosmic clouds, waiting for gravity to sculpt the next generation of stars. But these ancient objects, they were done. No leftover gas, no dust, just pure starlight, as if the universe had decided to skip straight to the finale. Astronomers were shaken. If something converts all its gas into stars, it can't evolve any further. It burns bright and dies fast. Such efficiency simply doesn't fit with the physics we know. It's like watching a candle burn out before you've even lit the match. And yet, there they are, defiant, distant, and dazzling, glowing from the edge of time itself. Then came the question no one wanted to say out loud. What if these aren't galaxies at all? What if we're looking at something completely new, something beyond classification? Some scientists propose they could be massive star clusters, ancient quasars, or even remnants of a universe that existed before the Big Bang. Others believe they might belong to a whole new category of cosmic object, something humanity has never seen before. And the oddities don't stop there. These structures don't behave like galaxies. They don't spin. They don't follow the elegant spirals or ellipses we expect. Instead, they're compact, chaotic, and strangely bright, almost like fossils of another reality, preserved from a cosmic age we were never meant to witness. If they're not galaxies, then everything changes, because our entire understanding of the universe, its growth, its age, its structure, is built on the idea that galaxies are its building blocks. But if these objects aren't galaxies, then what are they? Whatever the answer, one truth is undeniable. The universe is far stranger and far more alive than we ever imagined. Maybe, just maybe, we've glimpsed a lost chapter of existence, one that doesn't fit into our current book of physics. So before we dive deeper into this cosmic mystery, don't forget to hit that like button. It helps this video reach more curious minds like yours, because what's coming next might just change how we see everything. When we look into the night sky, we're not just seeing stars or space, we're seeing time itself. Every star, every galaxy is a time capsule, a glowing page from a story written billions of years ago. When we gaze into the night sky, we're not just looking across space, we're peering backward through time itself. The farther we look, the older the light, and with the James Webb Space Telescope, humanity is now reading the earliest chapters of the universe's story, pages that were sealed away for nearly 14 billion years. But even Webb has a limit. Scientists call this cosmic boundary the observable universe, a vast bubble about 92 billion light-years across, with Earth sitting right at the center of our own tiny perspective. Beyond that, silence. Not because nothing exists there, but because the light from those distant realms simply hasn't had enough time to reach us. And yet, here's where it gets wonderfully strange. The universe isn't static, it's expanding, and that expansion is accelerating. Galaxies on the far edges are racing away from us faster than the speed of light itself. Logically, their light should never reach us, and yet somehow it does. It's not that these galaxies are breaking the laws of physics, it's space itself that's stretching. Imagine dots on the surface of a balloon as it inflates. They drift apart, not by moving, but because the very surface between them expands. Light traveling across that balloon bends and warps as the fabric of space stretches beneath it. That's how we're still able to glimpse galaxies that should, by all rights, be forever out of reach. Astronomers call this expanding boundary the Hubble sphere, a bubble that slowly grows, catching rays of ancient light that were once lost to the void. But even this sphere has a limit, a cosmic horizon we'll never see past. Beyond that edge, light from those distant regions will never, ever reach us. It's the ultimate frontier of perception, not the end of space, but the end of what's visible. Yet most cosmologists believe the universe continues far beyond that horizon, maybe endlessly. If it truly stretches to infinity, then the Big Bang wasn't an explosion at all. It wasn't something that happened in space, it was the birth of space, expanding everywhere at once. That means the universe didn't begin at a single point. It began everywhere, simultaneously, in every direction, even in the regions we'll never be able to witness. When we stare at the edge of the observable universe, we're not looking at the end, we're staring at the limit of human sight. Beyond that veil could lie other universes, other realities born from the same spark. Because the beginning of everything, the Big Bang, wasn't a local event. It was a transformation of reality itself. And the echo of that transformation still lingers today. It's all around us, invisible but ever present. The cosmic microwave background, the afterglow of creation, whispering across the night sky. But now new discoveries challenge even that foundation. The James Webb Telescope has spotted galaxies that seem to have formed stars just 200 million years after the Big Bang, impossibly early. If that's true, then maybe our concept of time itself is wrong. Maybe the universe's clock isn't ticking the way we thought. And if that's the case, then what we think of as the beginning might just be another chapter in a story that's far older and far stranger than we ever imagined. Maybe, just maybe, time itself flowed differently in the early universe. Imagine that. The seconds, minutes, and millennia we know today might not have existed in the same rhythm back then. Or perhaps what we're calling the beginning wasn't the beginning at all. Some scientists now believe that under the extreme conditions of the newborn cosmos, our entire concept of before and after could have broken down completely. In those first flickers of existence, the laws we live by, gravity, motion, light, might have bent, twisted, or even paused. The rules of physics that govern your body, the stars above, and the galaxies we see today might not have applied. That realization opens a haunting and exhilarating door. What if the universe never truly began? What if the Big Bang wasn't a birth, but a transition, a transformation from something timeless, ancient, and beyond human imagination? If that's true, then the Bang was just one phase in a much larger cosmic cycle. There could have been universes before ours, each expanding, collapsing, and rebirthing across eternity. The beginning might not be a single spark, but a continuum, flowing endlessly, meaning time itself could be circular, not linear. It raises the most profound question of all. If time has no true beginning, then what does that mean for us, for existence, for the very idea of creation itself? And then, just when scientists thought they were starting to grasp these ideas, James Webb dropped another cosmic bombshell. In a recent paper published in the Astrophysical Journal, astronomers announced a jaw-dropping discovery: 87 galaxies that might have existed a mere 200 to 400 million years after the Big Bang. To put that in perspective, that's when the universe was still shrouded in darkness, barely an infant. By all logic, galaxies shouldn't even exist that early. Building galaxies is no simple feat. Gas must collapse under gravity, stars must ignite, die, and seed heavier elements. Clusters must form, merge, and evolve. That's a process expected to take hundreds of millions of years, and yet these galaxies appeared almost immediately, as if the universe hit the fast-forward button the moment it began. It's like opening a history book to the very first page and finding entire cities already built, lights on, streets paved, civilizations thriving. Even more unsettling, many of these galaxies look mature and structured. They don't look like the chaotic clouds scientists expected. They have defined shapes, intense brightness, and immense mass, traits that shouldn't have existed for billions of years. Astrophysicist Jing Yan, one of the lead researchers, put it plainly: even a few confirmed galaxies at this stage would force us to rethink the timeline of the early universe. These galaxies are too ready, too complete, too impossible. Some are more massive than theory allows. Others are forming stars at rates that should tear them apart. Together, they've created a cosmic puzzle, a pattern of anomalies repeating across every new Webb image. It's not one glitch, not one misreading. It's a chorus of evidence echoing from the dawn of time. And now, astronomers are realizing something shocking. The James Webb Telescope has proven that our cosmic clock might be broken. For the first time in human history, we might be staring at proof that our entire understanding of the universe's timeline is wrong, that what we thought was the beginning might just be the middle of something far greater. Would you still call it the Big Bang if it never really began? So what do we do now? Confronted with discoveries that defy every established theory, science stands at a turning point. Do we cling to old frameworks, patching them to fit the evidence? Or do we accept that something profound, something foundational, is missing from our understanding of the cosmos? Some researchers are already daring to think beyond convention. Maybe dark matter isn't the quiet, invisible background we thought it was. Perhaps the laws of physics themselves evolve under extreme cosmic conditions. Others explore more radical possibilities: a variable speed of light, ancient primordial black holes that gave birth to galaxies, or quantum effects stretching across the universe. Each theory attempts to explain the strange new data, but none provide a complete answer. And then comes the boldest idea of all, one that challenges the very fabric of reality. What if these newly discovered objects don't belong to our universe at all? What if they are traces of another cosmos, a parallel reality intertwined with ours, leaking through some unseen boundary of existence? If the multiverse is real, then those early impossible galaxies could be cosmic fingerprints, remnants of a neighboring universe imprinted upon our own. Of course, these are still theories, fragile ideas built upon the first glimpses of evidence. But that's how science progresses, not through certainty, but through curiosity, through the courage to challenge what we think we know. Many scientists urge caution, reminding us that extraordinary claims demand extraordinary proof. They are right to do so. Yet piece by piece, observation by observation, the weight of evidence grows heavier. The James Webb Space Telescope was built to glimpse the universe's first light, the birth of stars and galaxies emerging from cosmic darkness. But instead, it may be revealing something even greater: the edges of reality itself. We are not just revising textbooks, we may be rewriting the story of existence. So what's next? We keep looking, we keep questioning, and we brace ourselves for answers that may sound more like science fiction than fact. Because when the universe whispers its secrets, humanity must listen. The James Webb Telescope hasn't just captured the oldest light, it's illuminated the deepest mysteries: galaxies forming too fast, structures too advanced for their time, a cosmic timeline that no longer makes sense. Even the brightest minds, Nobel laureates and cosmologists, find themselves staring into the unknown. Are we truly seeing the dawn of time, or something far stranger? Another universe bleeding through, another chapter of existence hidden beyond our reach? Whatever the truth may be, one thing is certain: our journey into the cosmos has only just begun.